Hello everyone. Previously we had discussed on the topic this one, Floyd cycle detection algorithm, right? So today we'll be going with the topic merge two sorted linked lists, right? So this is also one of the important algorithms basically in the linked list. So many problems are based on the merging sorted linked list, right? So if you would have solved this one, this basically what do we call the LeetCode or the CP problem, some of the problems include so basically merging the two sorted linked list, right? So linked lists basically, this is fine. Now let's get into the definition part, what it says basically. Let's see the same. So here merging two sorted linked list means combining their nodes into the single linked list, right? So again, merging two sorted linked list means here combining their nodes into the single linked list that is sorted in the non-decreasing order, right? So again, that is sorted in the non-decreasing order. So this term is very important, that is sorted in the non-decreasing order. So we do this by repeatedly choosing the smaller front node from the two lists and attaching it to the result. No new node values needed, just relinking, right? So here we'll not be making use of any new node, instead we will be relinking, right? So that's what we'll be doing, just remember this one, right? So this is important. So let's get into the explanation part. Listen to this carefully. So the same thing will be implementing in the form of code or the algorithm, basically using the Python programming language. So just listen to this carefully. So we commonly use an iterative approach, right? So we commonly use an iterative approach. We'll not be going with this one recursive, we'll be going with a iterative approach with a dummy. So basically when we make use of the dummy, it makes our life easy, right? So that is the reason we'll be making use of the dummy variable, right? So within the linked list, most of the problems or the algorithms in the most of the problems or algorithms we make use of the dummy node, right? So don't get confused. So we'll be adding the dummy node so that it makes our life easy, right? So we don't have to write the code, lengthier code, so we can just make use of the dummy node, right? So we commonly use an iterative approach with the dummy or the sentinel node and a tail pointer and a what tail pointer, right? So first what we'll be doing, the first step here would be we'll be creating the dummy node, right? To simplify the edge cases. So that's what I said, we'll be creating the dummy node to simplify the edge cases here, nothing but empty list and the head replacement, right? So we'll be walking through the both lists here. At each step we'll compare the current nodes, right? So at each step we'll be comparing the current nodes, the first node with the first node of the this one second list, the first node in the first list will be comparing with the first node in the second list, basically that's what we'll be doing. At each step we'll be comparing the current nodes and we will attach the smaller one to the tail. The smaller node, what we'll be doing, we'll be attaching the value of the smaller node to the tail, basically, right? So further what we'll do, we'll advance the pointer, nothing but the tail, basically from the list we took a node from, basically that's what we'll be doing, right? So when one list finishes, we'll attach the remaining part of the other list. Suppose we have unequal number of this one, what do we call, values in the list. So we have only one value in the first list. Suppose I'll just show you the example here itself, right? So see here, this is list 1 and this is list 2, right? So we have the value only 1 here, right? So only one value, and here we have 1 3, right? So we have two values here. See, when one list finishes, we'll attach the remaining part of the other list. So 1 1 will compare, so it will be 1 1 basically. Then we have the value 3 left, right? So we don't have any value in the list 1, so we'll just attach the value of the list 2, right? So that's what we will be doing. So that's what it says here, right? So this is it for the algo. So basically what is the time complexity here? The time complexity would lead to big of n plus m. So this part, right? So we know that n and m are nothing but the length of the list, this one lists that we considered, basically here in this case I have showed you L1 and L2, so it may be two lists, L1 and L2, right? So whatever the name that we have given to the for the lists, basically, right? And the space complexity would lead to big of 1 extra space, nothing but here in this case we'll be reusing the existing nodes, only the dummy is extra here, right? Here also I have said, see here, no new node values needed, just relinking. I have stressed this one earlier because of this itself. The space complexity would lead to big of 1. Just remember this one. Time complexity big of n plus m, space complexity would be big of 1. So let's do one thing. Let's quickly start writing the this one code. Let's try to implement the same thing now from here to this one, right? Yep, here to here. So whatever we have discussed in the approach, let's try to explain it. Whatever we have discussed in the explanation, let's try to implement the same thing in the form of code, right? So just give me a second here, 1 second. Yeah, first let's do one thing. Let's define the simple single linked list node class. So I'll just come here. So this one will be class, this one list node. This is fine. So within the list node class, I'll be going with the initialization or the constructor part. So let me go with the init. Along with the self, I need some of the parameters here. Nothing but I'll just assign the value to 0 or initialize this one to 0. Also, I'll go with initialize next to none. This is fine. Next to none. Now let me go with the let me assign the value to the value itself. Then let me assign this one next to nxt or the next itself, right? So this is fine, man. Now let's do one thing. Let's consider one more function. So here within the class, let's consider the method of the function, this one, merge to sorted list. So this is the iterative merge function that reuses the nodes from the input lists, right? So accordingly with the approach we are going. So I'll just go with the function here or the method merge to this one, sorted lists. This is fine. So I'll just go with L1 comma L2. So this is fine, I believe. So first what we'll do, let me assign dummy to the list node. So this one is fine. Also let me assign tail to dummy. So this is also fine, man. Right, so this is fine. The next step would be, we'll be looping until one list becomes empty. So I'll just go with while L1, so this has to be L1 is not, while L1 is not none, and L2 is not none. This is also fine. When L1 is not none and L2 is not none, then we have to choose node from the L1, nothing but the list 1, when its value is less than or equal to the L2's value, right? For that, let's write the simple if condition. Well, if value of the L1 is less than or equal to value of the L2, then what we need to do, we have to attach the L1's current node to the merge list first. So this one we can write it in this way: tail dot next equals L1. Also we have to advance L1 to its next node, meaning I'll just assign the L1 to the L1 dot next. So basically we are moving the L1 to its next node, right? So this is fine. Sorry, yep. Next step would be, let me go with the else here. So else we have chosen node from L1 when its value is this one, less than or equal to L2. What if the value is not less than or equal to L2, or what if it is greater than the L2, right? Then we have to attach L2's current node to the merged list, right? So I'll just go with tail dot next. Let me assign this one to L2. Next we have to advance, or we have to move the L2 to its next node. So this one will be L2 equals L2 dot next. Basically this is fine. Yep. The next step would be, so we have to move the tail to the node we just attached, meaning I have to assign tail to the tail dot next, right? So this is fine, I believe. So we are done with this part almost. So let's do one thing. Yeah, now at least one of the L1 and L2 is now none. So then we have to attach the remaining non-empty list, right? So I had showed you that one, right? So if L1 if we have unequal number of elements within the this one L1 and L2, if the elements in the L1 is not equal to L2, right, then we have to attach either L1 or L2, right. If the elements are greater in this one L1 or L2, we have to attach them, right. So for that, let's write the simple if condition. If, let me go with L1 is not none, basically, right. So if L1 is not none, then what we'll be doing, so I'll just go with tail dot next. So let me assign this one to the L1. So this is fine. So we are just attaching the remainder of L1 here. So next what we'll be doing, so let me go with the else here. So this one is nothing but, so tail dot next. So let me assign this one to the L2. This is also fine. So finally what we'll be doing, let's return the this one dummy dot next, in the sense, let's go with a merge list that starts at dummy dot next. We have to skip the sentinel, right. So we have considered the dummy node. The name itself indicates that it is dummy, right. So we shouldn't consider it. We have considered dummy node only to simplify the edge cases. We shouldn't consider this one within the output, basically, right. So this one, let me return dummy dot next here. So this is fine, I believe. So let's do one thing now. So let's go with the helper method or the helper function to build the linked list from the Python list, just for the testing or the demo purpose, right, for the example usage, basically. Let's go with the two helper methods. One is build list, and another one is to list. Let's go with the build list first. So I'll just go with the def build list. So let me go with the parameter vals here. So this is fine, values. So let me assign dummy to list node. This is fine. Let me assign tail to dummy here. This is also fine. Next, let's go with a simple for loop. So this one individual value and vals I have considered, right. So this is fine. What we need to do here, so let me assign tail dot next to the list node of individual value that we have considered. Let's pass v here. Also let me assign tail to the, we have to move to the next one, right. So tail dot next. This is fine. Finally we have to return the we have to exclude dummy, right. So I'll just go with return dummy dot next. We shouldn't consider the dummy node. This is fine. This is it for the helper method build list. So one more helper method I'll be making use of here. So nothing but the to list. So this is the helper method to convert the linked list back into the Python list for the easy printing purpose, right. So this is for, basically this is for the example usage, right. So algorithm we have completed here itself, line number 44, right. So let's make use of one more helper method here. Nothing but I'll just go with to list here. This one, let me pass head pointer here. So let me assign result to the empty array, also current to the head. This is also fine. And while current is I'll just go with not none, then what I'll do, within the while loop, let me go with result dot append. So let me pass here current dot value, basically. So this one will be current dot value. So let me go with the, let me assign current to, we have to move to the next one, right, the current pointer to current dot next. So this is fine. Next is we have to return the result. We are storing this one in the result array, right. So we have to return the result. This is fine. Yep. We are done with the helper method to list as well, right. So this is fine. Finally let's go with the example usage. So I'll just take two variables here, two objects, basically a and b. So let me call the build list, this one function here, or the method here. So let me pass the list L1 here. Let's create the list, some random numbers I'll give. So I'll just give here 135. This is enough, I believe. I'll also go with the list 2. Again I'll just go with the build list here. So within the list, so I'll just go with 2, 4, 6. This is fine. Yep. Now let's do one thing. Let's merge them. Right. For merging them, what we have written? We have written merge to sorted list. This one function or the method. Right. So I'll just give here merged equals. Let me call the method here or the function. Let me call the parameters a comma b. This one a and b variables. This is fine. Yep. We have successfully merged them. Now let's print something for the interactive purpose. Right. So I'll just call to list here. This is fine. Of let me pass merged. So this one. So the output that we need to get here is 1 2 3 4 5 6 after merging them. So this one it will compare with this one. So 1 with 2. So which is smaller? 1 is smaller. 1 will be printed first. 2 will be printed next. So 3 4. So this 3 will be compared with a basically this one. Yeah, this 3 will be compared with the 2. So 3 is larger than 2, and also 3 will be compared with the 4. Basically 4 is less than 3, right? So 3 will be printed first and 4 will be next. 1 2 3 4. Finally same goes with the 5 6 5 6. The output that we need to get here is 1 2 3 4 5 6, right? So let's check the same here, right? So I'll just come here. Let me copy the file name. This is fine. I'll just give here Python this one dot py. So Python can't no such file or directory. So yeah, yep, let's do one thing. Both let's remove the space here. This is fine for this one as well. Java file. Usually I practice with both Java and the Python. So let me do one thing. Yep. So this one. Yep. Now if I run this one, yeah, we are getting the output. So we are just getting the 2 4 6, right? So we have to get the output 1 2 3 4 5 6. So somewhere we have done something wrong here. This one. This is not getting displayed at all. 1 3 5 basically. So let's check what we have done wrong here. So what mistake I have done here is in the line number 37. So see here, this is the indentation problem. So we have to move this one, right? So this is fine. Now in the line number 40, so we are assigning the tail dot next to the L1. Instead I have mentioned the hyphen or minus operator here. So this has to be equals, not the this one minus operator. So this is fine. Now if I run, this has to work correctly. Let's check. So yeah, now we are getting the correct output 1 2 3 4 5 6, right? So this was the problem. One was the indentation problem, this one, line number 37, and we have to assign this one to the L1, not minus operator here, right? So that was the wrong thing. So now we are getting the correct output or the desired output, right? So let me explain whatever the output that we have got here. So basically the printed list, so this one, yeah, the printed list here shows the node values of the merge linked list in the order, right? So this one 1 2 3 4 5 6, we are getting this one in the order. One came from the list A. See here, one came from the list A. It was the smallest initial value, so we'll be comparing with 1 and 2. 1 is the smallest value, right? So 2 came from the second list B, nothing but the B. See here, this one, right? Then same thing, then 3 from A and 4 from B. See here, 3 is small, smaller than the 4, so it came after 2, basically 3 4, and 5 is smaller than the 6, so 5 came first and 6 came next, right? Each step which took the smaller current node. Each step we have took the smaller this one, yeah, we have took the smaller current node. This is fine. So the final list 1 2 3 4 5 6 is sorted. This is sorted in the ascending order, right? So the final list 1 2 3 4 5 6 is sorted, and it contains all the nodes from both input lists here. So this one A and B we have considered. Usually I considered this one. Usually we take L1 and L2. Instead I have considered A and B. Don't get confused here. This is fine, right? So now we are done with a merge to sorted linked lists algorithm, right? So I hope this part is completely clear, man. As we are completely done with this algo, let me summarize whatever we have learned so far, right? So just keep these 3 or 4 this one things in the mind, 4 points in the mind. First thing is, merging two sorted linked lists can be done in the linear time by walking both lists and linking the smallest current node to the result each step. Again, merging two sorted linked lists can be done in the linear time by walking both lists and linking the smaller current node to the result each step, right? So the second step here would be, let's make use of the dummy or the sentinel node to simplify the edge cases and return the dummy.next as the merged head, right? So making use of the dummy node as what it does, it makes the life easier, meaning we'll be making use of it just to simplify the edge cases. Just remember this one. Most of the linked list problems you make use of the will be making use of the dummy node, right? Usually when solving the problems as well, right? So this is fine. Now we have made use of the iterative approach. We are not going with the recursive approach, right? So we have went with the iterative approach, which is big of n plus m time, or m plus n. We know this one, we have already discussed, and big of one extra space, nothing but the space complexity. The time complexity would be big of n plus m, and the space complexity would be big of 1 in simple terms, right? So, and one more thing which is very important here is, whatever the method that we have made use of iterative approach, so this method to merge this one two sorted linked list, basically this reuses the existing nodes, right? This reuses the existing nodes. So we are not making use of any extra node values, right? So we are not creating any extra node here other than the dummy. So this makes memory efficient. So this is very helpful in this way, right? So basically we are reusing the existing nodes. We are not creating any extra node other than the dummy node, right? So this makes this algo memory efficient, right? So as we have went with the iterative approach as well, so this is one of the biggest advantage of making use of this particular algo, right? So I hope this part is completely clear. I mean, this algorithm is completely clear. So we are done with the merging two sorted linked list algo, right? So next we'll be going with a reversing a linked list algorithm, right? Usually we'll be going with a reversing a linked list or reverse a linked list algorithm. So we are left with 3 algorithms: reverse a linked list, detect and remove loop, and cloning the linked list with a random pointers. Next we'll be discussing the reversing a linked list algorithm. So for now this is it. Thanks for watching, guys.